Yeah, so my name is Jerry, if this is the first time you're seeing me. And these two are the... Introduce yourself, Phil?
Hey, what's up? I'm Philip. So I've been doing machine learning stuff for about like 2 years now. Basically came in with these two to make this class because I'm really excited about it and I want to teach all of you.
And hi, I'm Joseph, and most of the stuff that Phil said also goes for me.
All right, cool. So yeah, just start with hopefully all the basic information is up there. Also, if you did a good poll, we updated the syllabus to better reflect what's going to happen in the next few weeks. Basically, all the grading stuff, attendance policy, and general schedule is all laid out for you. So please check it if you have any questions. Also, we have a Piazza page. If you're not enrolled, if you're not in Piazza, please join it because it includes some helpful information for you. And yeah, if you haven't signed up, please sign up using the tiny URL. All right, cool. So generally, to just get things started today, this is the outline. Hopefully, we can end things a little bit sooner because people have apparently have midterms at 8 p.m. and we would like to, and it's technically the first day, so it's something we can accommodate. So for first things up, I'll just take a tour with Kaggle since you haven't really gone onto that site yet, and then we'll take a look at one of the entry-level data sets for Kaggle, which is classically the Titanic Dataset. And then after that is basically just an overview of some summary statistics functions that you can do and also data visualization stuff that you can do. All right, so that was a quick overview. And now I just want to generally get started on like introducing the main data set that you guys will be learning for today, also on Wednesday as well. So it's a Titanic data set, and for those of you who don't know the history of the Titanic, it was a very, I guess, infamous time in U.S. history where a bunch of people from Europe, Southampton, Cherbourg, Queenstown were on one of the largest ships at that time, sailing to New York. And so in 1912, they made this journey across the Atlantic, and then they got hit by an iceberg, and unfortunately, a lot of people died. And so it's interesting in that the data set for this is like publicly available. Although it is kind of messy and scratched up a little bit, it does have like most of the information about these passengers. And so what happens is that we can actually use this piece of data set in order to predict whether someone who survived the journey or did not survive the journey based on certain attributes. Yes. Oh, sorry. Actually, hold on.
Oh, it's plug it.
There is a microphone here, a rather non-standard one, but all right. Can you hear me now? Cool. All right. Awesome. Okay. So what was I saying? Oh yeah. So that's basically a quick overview of the Titanic, and the next slide is basically some facts that I found online. So the Titanic could carry like 32 lifeboats, which theoretically could hold most of the people in the Titanic, except that for various reasons it reduced down to 20, either like cost-saving measures or actually apparently it was standard practice to not have all the lifeboats on a certain like all the lifeboats at maximum capacity for whatever reason at that time. So there's that information, as well as you probably heard of this, or some of you have, a woman and child first or only policy on the Titanic, in which men were deprioritized in getting them onto lifeboats. So if you look at the data and probably intuitively, you'll think that being female will have a higher chance of survival because of this policy that was enforced on this boat. And also they were enforced differently depending on which side of the ship you were on. Okay, so before I open, any chance?
Do you need?
Yeah, I want to open.
Okay.
All right, so if you can navigate to the day 4 code directory, you should see I think two fonts. One is the Python notebook, and the other is just a not notebook but just the script. Go ahead and open the notebook, and then we'll start from there. All right, awesome. All right, so actually, let's see. I'm just gonna actually let me just pull this real quick. Yeah, so inside this notebook, you'll find most of the things I will be talking about today. But in order to give it more interactive, I'm going to just create a new notebook for you guys so that you can see like how I do things. Okay, and I'm just going to cheat and just copy this cell over. Actually, this is really uncomfortable to type with one hand and holding the microphone in another. So I'm just going to like put it down while I type, and hopefully you guys can see it clearly. Hopefully. Okay, so let's see, where's the data set? Actually, let me just try something real quick. So usually when I begin like doing code, I want to import all the modules that I'll be using. So in this case, the standard like module is to get pandas, numpy, and matplotlib out, as well as to use the magic function matplotlib inline in order to make all the plots render inline on the notebook for you instead of doing plt.show. So yeah, so in order to read in the data, you should have the data inside the datasets directory. So let's see, let's call it df equals to pd.read csv. And oh shoot, hey Phil, does your path directory go to, like I'm not familiar with your path.
Just do dot slash. Just do dot slash name.
As in like I have to go up a level.
Dot slash.
Okay, dollar slash, and then it's datasets, Titanic, CSV. See.
Cool. Probably didn't recognize the name.
Oh, you know what? Hold up, I have an idea what's going on. Oh, it's not exciting because it's up here, right? Yeah, let's do something real quick. We'll just restart it. So this is the one that you need?
Yeah.
Yeah, should be good.
Okay, cool. Awesome. So, yes. Oh, oh shit. It does not exist.
Are you sure it's datasets or just data? Do dot slash. It's not dot slash.
It's what?
It's just dot slash now.
Dot slash now? Okay.
Is it?
Yeah.
Oh man. What does it say here? Can you go back to here? So we're in top level, right?
Two levels. Okay, that might explain it. Is it dot dot?
Oh wait.
More dots theory.
I'm not familiar
we can
with
try
dots.
Okay, that works. Yeah.
Okay, that worked. Okay, cool. Thanks. All right, awesome. So if that worked, then in theory we can do this, dof.head, and then you'll be able to see the first 5 lines of the data file.
Who hasn't been able to load the data file themselves, by the way?
Yeah, if you have any problems, just raise your hand. One of us will get to you.
Okay, is it just me? Okay, so someone else. Okay, cool. All right, so hopefully you didn't have that much trouble, but in general, when you load data, you want to load it with a pd.recsv, and then immediately if you want to check out what the data contains, you do a df.head. Also, another useful function is df.shape. And then you can get the dimensions of the data frame, so 891 rows by 12 columns. You can also do other general diagnostics like, let's see what else. df.describe. So what describe does actually is it pulls all the numerical columns. Actually, I should use the microphone. It pulls all the numerical columns and then calculates basic summary statistics for you, like the min, max, the quantiles, as well as the average, and also, importantly, on the top, the number of non-unique values in that column. So if you notice, all of these have 891 values except for age, because age actually has a ton of missing values. So that indicates that age is in theory, a problematic variable going forward. So there's the describe, and basically you run these functions as like general diagnostics to see what data look like. You can also do df.info, and then it also gives you like some data on like the number of missing values this way, and also the column types. So yeah, anything else I wonder? Not really. So for example, let's see. And you can immediately start playing around with like statistics. Say this will grab all the age data in that column, and then you can run a mean function in order to get the average. All of this is already summarized, but this is just how to run the computation using a function after selecting the column. What else? df. Oh yeah, so df like survived. Mean, we can do that. About 38% of people survived on the Titanic, at least with this data set. You can also do, you can also use this function. And value counts will just count the number of unique values and gives the overall running count for you in a simple manner. So if you come from an R background, this is basically what table does. And it's a very convenient way of just tabulating all of the things inside a particular column. Okay, cool. Any questions so far? Yeah. Yeah, so value counts, it grabs all the unique values inside the column, so like in this case numerics, and then just counts how many of those occurs. And so it gives you like a table of like there are 342 ones in that column, 549 zeros in that column. If we were to use, if we were to use a different column, for example, what's the interesting column? I don't know, P class, value counts. And then you get like a different output from that. And then also, by the way, P class represents the in general, the socioeconomic status of the passenger. So 1 being like first class, and then 3 being third class or the lowest class. Any other questions? Yeah.
I noticed it's only like 891, right?
Yeah.
It's like 2,000 something around 4.
Mm-hmm.
Are all the rest on the test set? Or
This, yeah, so there's some in the test set, but actually I did look into this a little bit. This is not everyone. so this is like, for whatever reason, not like all the people inside this data set. And that's also because like there's like missing records, right? And so like there's some people you just can't find. And there's some documents like it's just nowhere to be found. Also in general, like if you go out, search like for this data set on Google, there actually be like files with like 1,000 people or so. And so like I actually have no idea why this only has 891. But this discrepancy shouldn't really matter too much for the sake of like analyzing stuff. Cool. Anything else? Okay. So next I'm just going to hopefully explain something that will be useful for you guys, so you guys actually learn some stuff in case you haven't learned this already. So in summary statistics, one useful thing to do is to apply like an average across like certain categories. Like if you're male and female, like for example, what's the average survival rate between males and females? And so this is where the split apply combine technique comes into play, where you're literally splitting the data into different compartments based off the category. So like splitting the data according to males, splitting the data according to females, and then running the same function on both departments at the same time, and then combining the results together into one neat table. So this is basically what this this visual does. If you look at the key, oh shoot, it's not that hard. It's not that easy to see. But if you look at the key, it's basically splitting A, B, and C into its different departments from the data. And then you apply, in this case, the sum function to each one of these. And then you get an aggregate total of 15 for A, 30 for B, and 45 for C. And so this technique is generally what you would use with GroupBy, in which I'll explain next. So for this function, so the concept is there, and then what Pandas does, it gives you the function called GroupBy in order to get the split functionality working. So GroupBy, for example, sex, or in this case gender, will group the data according to that column. And so that column actually has two values, male and female, and it'll just split the data set into basically two things invisibly behind you. So what it returns is basically a GroupBy object that are data frames. And then what you can do after you split the GroupBy, split with the GroupBy, is apply an aggregate function. So in this case, so since each department is basically a data frame, I can actually, and this is a little bit syntactic sugar as well, I can select the column, the individual column of each of those data frames unanimously by calling the column with this syntax. In this case, I'm just calling the survive column. And then I can apply the aggregate function, in this case average, to get the average survival rate per gender. And so immediately you can tell that females had a much higher survival rate and the males were not as lucky. Any questions on the concept? Yeah. Oh God. Okay. All right. So I guess I will stick to this way for PowerPoint slides, and hopefully you guys can hear me while I code. Actually, you don't need to hear me. You can just follow my code when it happens. All right. Cool. Any questions? Yeah. Line 14. Yeah. So so you understand what line 13 does, right? It grabs the data and then splits it into the individual compartments, right? And so after that is done, then it selects one column from each of those data frames. So in this case, it's survive. This is just like syntax to basically select all the columns simultaneously, which is basically what, well, in this case, this is a good visual of what happens. You get each of these departments and a single column corresponding to each category. And then what you can do, what you can do is apply a function, in this case .mean, and then .mean which is take the average of each of these columns for you and combine them into a single tabular form like so. And so for the Titanic dataset, if you were to run this line, you will see this as the output: females and males, and then the average survival for each. Does that make sense? Yeah. All right. So so basically, I explained what that you can attach a function called mean, but you can also attach any kind of function that you want. And this is what aggregate does. So aggregate is a method that allows you to pass in functions of various forms. You can pass in your own functions, or you can pass in standard NumPy functions. And you can pass in multiple of these functions in order to compute multiple of these statistics at the same time. And so what line 16 does is it computes the mean, the size, which is basically the counts, or the number of, elements inside each column, and also the standard deviation for each of the data frames that get generated from the GroupBy. And so what gets outputted is this really neat data frame of females, males again, but also each of these statistics as their own column. So this is just a really, really fast way of doing things simultaneously. And also the aggregate, if you want to use aggregate or AGG, then all the functions that you pass into it must return a single value, because that's what it is expecting. AGG stands for aggregate, and then what really you should be thinking is you should aggregate all the data points into a single number or a summary statistic in the end. Any questions? Yeah. Don't use what? Survive. So, so if you don't pass in survive, what it tries to do is apply the function to all of the columns. What T is, it basically are individual data frames at this point. And if you don't pass in a column, then AGG will try to or attempt to apply the function for each column. And if it's successful, then it'll give you like outputs for every single column. You should try that by yourself to see what that looks like, but it might be a bit ugly. Yeah.
Will it give you new columns that have the mean and the standard deviation, or will it just like put the mean in lieu of what it said before?
Putting the columns where?
Like, is it going to create 3 new columns for the mean and the size and the standard deviation?
Yes.
On every single column if you don't have survived it?
Oh yeah. So if I don't have survived, then it will try to do mean, standard deviation, size for every single column, and then there'll be multiple tables. I would imagine there'll be multiple tables. I haven't looked at it myself, but it's pretty ugly. Generally, like you don't want to be you don't want to be like not selecting any of the columns. You should try to select a single column in order to like understand what that column actually resembles after you apply a function. All right, and the next thing you can use is apply instead of aggregate or AGG. And apply essentially does basically the same thing. You can give it a function, except that you can only give it one function and not like multiple functions. And so immediately in your head, I'd be like, wait, so what's the purpose of using apply? And the neat thing about apply is that you can pass in a function and you don't need it to return a single value. And so, like for example, if you want to return like a list or an array instead, it will let you do that. And then it will give you like some kind of output as best as it can from using apply. And so actually, let me see if I can give a quick example of what that means. Right, so let's see, t equals to df GroupBy. Oh yeah, I should probably raise my voice. GroupBy sex, and then we get t. What is t? T is a GroupBy object, and then what I want to do is select survived. Use a function, and then pass in an anomalous function. Lambda is basically a syntax for creating your own function in one line. And then let's see, what do I want? Let's see. Oh yeah, another thing I forgot to mention is that when you pass, so what x is basically in this case a series, and you can't, and in order to like access the values of the series, you need to use this dot notation, dot values, which basically grabs the series and turns it into an array for you. And so after that, I can probably select the first 5 elements, and then it will give an output of this table over here, which basically what it does is like for each data frame that I just separated, it will take the first 5 elements of, in this case, it's not a data frame, it's a series. And so it would take the first 5 elements of the series and try to concatenate everything together in some meaningful way. If you were to try to do this with AGG, it won't work. It'll give you an error because it expects an aggregated value. So that's why you want to use an apply sometimes, and that's why you want to use the AGG function sometimes. All right, make sense? Cool. All right, and then just another slightly related thing. So for apply, it actually has different behaviors depending on like what object it's being like used in. So for the GroupBy object, so that's the thing that I just previously talked about. That's basically the functionality it has. You pass in a function and it gives some kind of aggregate value. For the data frame, for example, if you do not have a GroupBy object and instead just did apply on a data frame, then what it does is that you can apply a function, but apply that function for all the columns if you pass in axis equal to 0, or all the rows if you pass in axis equal to 1. So if you come from like a R background, this should be familiar as like the standard apply, lapply, or sapply statements. Actually, just the apply statement, and then it basically uses the function on each row simultaneously and each column simultaneously. So in this example, it would just apply the summation of all the numerical values of the original data set, and then you see the output in this way. And so generally, like for axis, 1 will correspond to columns. It's just that in this case, it's weird in that and this is probably the special case for for things, or in Pandas. When you use the apply function, axis equals 0 refers to the columns, and axis equal to 1 refers to the rows. So I hope that was not confusing, but I just wanted to make that distinction. Yeah.
What is the include argument that you want to describe?
Wait, what?
What is the include argument that you want to describe?
Where's include?
Slide?
Wait, can you repeat that question?
What is like the include argument you do in Dataframes?
Oh, you're looking at the
Notebook.
the notebook. Oh yeah, so I forgot to mention that. So this dot describe would take all the numeric columns of your data set and then compute like some summary statistics on them. You can't do that with categorical data, which are like strings. And so what include does is basically you can tell it to include certain data types. In this case, O, if you do include and then the list O, then it will include all the objects, which are in this case categorical values, and it will compute it differently instead of like instead of the aggregated statistics that you saw, like the quantiles. So I think it will compute the the unique counts of each one. Actually, I'm not too sure. You should just check it out yourself. It's just another way of looking at categorical data types. Cool. Any other questions? All right, so next up is just data visualization stuff. In general, there's really not much of a hard and fast rule of how to learn these, except for like just searching them yourself and applying to the data set that you think is reasonable. So I'm just going to list like the general things that you should probably have heard already. Histograms, you can do that for numerical data. So the left side is just a histogram of the age values and the Titanic. You can also apply a function called density, or actually, no, it's a dot plot and then kind equals to density. And that would just plot the density curves for, in this case, for each the males and the female age groups. And so actually, something worth pointing out is that you can plot stuff after a GroupBy, and that will, and Pandas will automatically plot the GroupBy data frames for you in a very convenient manner. And so that's why you see two plots generated automatically from that line. And you can plot scatter plots too. And for categorical data, you can choose to use bar plots or stack bar plots. And those are really just the standard like tools that you use if you want to look at something very quickly. So yeah.
So when you use the dot plot and then kind, or when you use the dot directly
So for so let's see. I'm trying to
I
remember.
wouldn't worry too much about trying to learn the like specific commands of matplotlib. Like, frankly, when I try to do most Python plotting, I still just Google like matplotlib make histogram and copy whatever their code is, change the labels, and go for it. I mean, like, don't worry, especially when we like cover all these libraries, about trying to learn specific functions. Much more useful is the ability to look up documentation and use it, because just trying to keep it all in your head would be hard.
Yeah, and the best way to learn is to like so we're going to like try to force you to do that by giving you like assignments and projects. So that's what those things are for, so that you can do these searches yourself under like a class environment. So just to answer your question, I'm not particularly sure if I remember if there's like a hard and fast rule between like using plot and like hist or like the other functions. It's just like I think out of my experience searching stuff that it just so happened to be this way, so I just copied it.
It makes them act interesting. If you can't in a notebook, it shouldn't really matter, but when you're working on like creating new images from a .py file, like off the command line, I think plot has some special behaviors.
Oh, okay. Yeah. Generally, like if you get an error, fix it by doing something else, and usually that something else is a different syntax. So, cool. Any questions so far? All right, and then the next thing that you can do, and this is actually not something that Matplotlib has, but if you download I didn't write down the package name, but if you download a package called missing no, I think that's what it is, just do like pip install missing no on your computer. you get this really nice package that allows you to visualize missing data in your data set. And so for this data, this is the Titanic data, and then you can obviously see where are the missing values inside your columns. And so for age, it's it's here and there a little bit missing. And then for cabin, there's a whole lot of data that's missing out there. So immediately you can tell that cabin is something that you should probably worry about and figure out like how to deal with later. And then on Wednesday, we'll talk about like how you actually deal with these missing values. But anyways, so yeah, so it's in case you're wondering if you want to know like how to get this installed and how the code works, you should come talk to us like after class, and so that we can help you run that line. Cool. And so this is basically the end of the class, and then I just want to leave with the announcement that Project 1 is up. So if you go into the project directory, there should be a Word document where it will detail the project specifications and basically all the things you will need to know about in order to accomplish the project. So it has the details, grading details, how to write your notebooks, and a few other things as well. So just an overview of what Project 1 is. This is a house pricing knowledge dataset from Kaggle. It was released just recently, and it's a really good dataset if you want to explore like all the information all the information that corresponds to like what makes a house price, at least in a particular location in the country. And so there's like numerical features, there's categorical features, ordinal features, which basically are like categorical features, except the 1s and 2s and 3s actually mean something. Like 3 is higher than 1. And what else? Yeah, just go ahead and play around with it right now. It is due in 2 weeks, and basically what you want to do is form teams. So you want to form teams of up to 4, and then get together to start working on this project, as well as eventually submitting onto the public leaderboard. So if you notice, this isn't actually an in-class competition with our own dataset. This is the actual dataset from Kaggle. And so what you'll be doing is actually submitting a model onto the public leaderboard once you learn the models next week. So, but for now, like, go ahead and take a look at the data set. You already have like basic understanding of how to visualize the data. And so what you should do is go ahead and download the data and then try to make some plots and figure out some patterns if you can. Any questions? What? Then you get, I forget what it was. It's a knowledge competition, so I think you get swag.
Is that like Kaggle shirts, or is it like
I have no idea. Whatever it is, you just search it up and you see what you get. It's not something that like monetarily rewarding, but if you do win it, like congrats. Actually, I think you shouldn't be able to win it unless you like cheat, because this data set is actually public, and so you can actually figure out the results, I think, if you search hard online. So, but yeah. Anyway, so steps in order to do this. Create a Kaggle account. We're ending the class now, so go ahead and form teams or try to find people, and then form the teams by basically next week, and so that we can keep track of like who's who and who's like working with each other. Cool. Any questions? All right, and that's about it.